Dzień dobry. Did I get it right? Okay. I use my one thing I can say in Poland.
Tak.
Tak, okay. Okay. So can everybody hear me okay? Okay.
All right. Can you hear me? Yeah? Okay. Let's get started.
Okay, let's get started.
All right. So the talk we're going to talk about today is pragmatic, not dogmatic, TDD, rethinking how we test. And so I just wanted to say it's my pleasure to actually be here. This is awesome. And hopefully we get you some ideas about testing that are new. All right. So I want to introduce my colleague, Joe Yoder. He's not wearing shorts today because it's a little cold here in Krakow. But
plus, this is all I have.
This is all he has. His luggage did not make it here yet. So, but anyway, Joe is well known for being one of the original guys who was involved with refactoring before refactoring was even given a name, right? And so he's founder of the company, The Refactory, which is a bunch of his colleagues from the University of Illinois, Champaign-Urbana, and they built the first refactoring tools. And so Joe believes in keeping code clean, although he's well known for the big ball of mud pattern. How many of you have heard of big ball of mud? Well, that's Joe. All right. All right. Okay.
Scary.
Okay. So Joe is also someone who likes adaptive systems. So he's written and implemented several of those systems, highly flexible systems that use metadata. So if you want to find Joe on Twitter, his handle is MetaYoda. MetaYoda, not Yoder. Yeah, MetaYoda. Okay.
Okay, so let me introduce Rebecca, okay? I've known Rebecca back from my early days. By the early days is when I was in the 90s, really involved with patterns, and I was an old small talker at that time. Ralph Johnson, one of the Gang of Four guys that I was doing my research work with at the time, he says, Rebecca's somebody you need to talk with and know. And he pointed out Rebecca, and she would be at these small talk conferences I went to. And so I went out of my way to get to know Rebecca, and we started getting involved there. Now, the interesting thing about Rebecca is she brings a lot of experience. How many of you in here do TDD? Wow, quite a few. Or maybe you've heard of DDD, domain-driven design, these other types of things, right? Well, Rebecca did the first DD. So if you want to blame DD on anybody, Rebecca's the one you can blame it on, because before there was TDD or DDD or any other DD, there was RDD, responsibility-driven design, and Rebecca wrote a book on it long before there was any of the others. And in fact, she was one of these, because she was, as I said, I met her in the small talk community, but she had originally come from the testing arena, so this is very relevant. And she was very committed to what good design, but lightweight methods before there was Agile. So long before there was Agile, you know, with doing lightweight, CRC, and other types of things, Rebecca was committed to that. And so she's been around for quite some time and got a lot of experience, but also notice Rebecca's in great shape. She just ran a marathon, 20-some miles in Portland a couple weeks ago. So she can definitely run me into the ground when it comes to running.
Right, and I finished 5 minutes faster than I did the year before. Even though I run slowly, I try to improve.
So, yes. So that was kind of interesting. A lot of you know TDD. So what I want to do is just, let's all get on the same page and think about what TDD is before we move on and kind of challenge some of the thinking of it. So, I mean, at the real core of it, when you really think real lightweight, TDD evolved from extreme programming. Have any of you heard of extreme programming? Some of you? Have any of you done extreme programming? Yeah. A few of you. Yeah. But actually, before there was Agile, there was this thing, there was these lightweight methodologies before they formally called it Agile and did the Agile Manifesto back in 2001. But back in the late 90s, some of us were doing things like extreme programming. And that's where TDD actually evolved from. And it was really kind of committed to this, well, we're going to be getting these good requirements, these nice little user stories. We'll write some tests about them. We're going to make sure these tests pass, and we're going to constantly keep our code clean. Kent Beck had pushed it at that time, and there was this big emphasis on doing this evolution and doing the simplest thing possible on that. And what was really at the core of that, of TDD, when you really think about it, you add a test. When you're adding the test, that's really where you're designing the class interface or the expected behavior. And then what you do is when you actually make the test pass, that's where you're actually implementing the most simple solution to do that. And then what you're doing as you're refactoring, this is when you adjust the class design and keep the implemented code clean. And so then if we start seeing patterns of duplication, or we want our design to change or the architecture to evolve, through refactoring is where this happens. And so one way of thinking about it, so Rebecca and I put together a little bit of a diagram here to reveal that, is you always start, if you're purist, dogmatic about TDD, you always start with you must write a test first. You know, the purist, in fact, there's tools in Java to really help. If you write the test first, then it'll help you define your class interface based on that test. Not all languages have that. And then, obviously, if you write a test first and you haven't implemented the class, it should fail. It could be you're writing a new test for something that's already there, so maybe it still passes, but we'll challenge the thinking on that as well as we go on. And then you write production code, and you keep doing that until everything passes. And constantly doing small little refactorings as you're going until ultimately they all succeed. Then you decide, should we start with a new set of user stories? Do we have more stories in this sprint? Or are we at the time where maybe we're ready, we can release something and we can go ahead and ship it? And actually, how some people look at this is this could actually be seen as test first development is another way some people have called this. So another way to think about that is from test first.
Okay, so when you think about why people really get excited about TDD is we want to have good clean code, we want to be able to move fast, we want to have a design that keeps working as we add more code. And so if I have tests, then I should, the promises, now whether they actually deliver or not, we're going to talk about, is that I'm building the right thing and that as I test, it's guiding what I'm implementing. So it's guiding my development. I'm not just wandering around doing, programming for fun. The tests are guiding me, they're keeping me focused. And if I have tests that I make sure that they pass, then I can make changes safely without breaking too much, as long as I have that discipline of making sure my tests pass, right? And so I'm making sure that what I'm working on code-wise is always working, which is like really a radical difference from write a bunch of code for a long period of time and then it doesn't work. And so hopefully we end up with good quality code and that the design is good too, right? I mean, that's the promises of TDD. But we invite you actually to keep an open mind about TDD. For those of you that are practicing TDD today, maybe we'll try to jar you to thinking about some other things about testing. And for those of you who are not familiar with TDD, or you didn't want to do TDD because you thought, oh, I don't want to do this test first stuff, maybe we'll offer you some options to think about. So please keep an open mind about this talk as we get into it.
So we really want to challenge you as we're going here. Yeah. So expect, because a lot of you are doing it, and maybe you're purist about it, so.
Yeah. So one of the first questions, and those were the promises, so we want to ask some questions and have a dialogue about TDD as we know it. Do tests really help you build the right things, Joe? Okay.
Well, that's a good question. So, 'cause that's one of the promises. And I guess a lot depends, because there's this common misperception, you know, is test is going to verify program correctness. Well, I guess maybe, but let's look at, for example, like that 3.14, that number there that looks pretty familiar to all of us. Now think if I was giving a number like that and I'm writing some tests and I'm being kind of the hardcore, okay, so let's see, it's bigger than 3, it's less than 4, test green, okay. Okay, so far things are cool, but you say, well, what about 3.2? That's not right. Well, okay, it's bigger than 3.1 and it's less than 3.2. Well, yeah, but what about 3.15? Well, then I say, well, maybe I need to rethink how I'm testing this. In reality, maybe I should say, well, it's a 3 followed by a decimal, and then there's like these different numbers, like, okay, we have to have a 1 and a 4. A 4 must follow a 1, but then a 1 must follow a 4. And maybe I start writing a bunch of tests, or my test evolved to something like that. Yeah. So, I mean, in reality, maybe, so if I don't have the right type of test, that's what's really key to this, is I really need to understand what the important kinds of tests are if I'm really going to test program correctness. So really, maybe if I was looking at the fact that pi is the ratio of a circle's circumference to its diameter, and maybe I could even think in polygons and get little rectangles in there and do something like that, maybe I would have a much better test.
Right. So if you just write the simplest test that passes and the simplest code that makes the test pass without thinking about what pi means, that's not going to get you very good code, right, Joe? Right.
So what's really important, if I am really going to, just because I have a lot of tests, if I just have my red-green blinders on, you know, and do the simplest thing possible, if I don't really understand the important parts of the requirement and what the user story is, I may not really, just because I'm doing TDD doesn't guarantee program correctness.
So when you're saying that, and just so I want to understand that, my test can pass, and I'm not writing the right thing?
That's very possible. If you have the wrong kind of test, so what? It's all green. That doesn't mean that it's going to pass. I mean, the test will pass, but that doesn't mean that it's going to meet the requirements of your actual user. That's where it's really important to understand the requirements and understand valid types of tests that will meet those requirements. Then tests can really help us. And in fact, it's more like an inductive way of doing it rather than deductive, or no, you get the feeling of inductive rather than deductive. Just because I keep adding tests doesn't mean it's going to inductively prove it's right. It's more like we're making some tests and we're trying to deduce this based upon good scenarios. Okay. Now similarly, when it comes to well-designed code, tests only say it works. You know, it doesn't say anything about the inside. So, for example, I even think of like the iPhone. A lot of you here probably have the iPhone. I remember when the iPhone first came out, it has this wow factor, really cool, and all the things you could do. Well, just because it was cool on the outside with the interface, what happens if the battery went bad? Man, the inside's how to get to it and change it. So just because, similarly with code, just because you have something on the outside the tests are passing, you could still have a ball of mud.
Yeah, you do like the mud, don't you?
Well, I try to avoid it, but I know it's a reality. Yeah. Tests don't prevent it.
Okay, so let's understand tests then, because if they don't guarantee good design and program correctness, well, they do something for us, right? Or we wouldn't be doing it, maybe. Okay, so if I think about understanding tests and really what they do for me, I have something that I'm testing, a target. When I write tests, I change something in my running software. I have a target that I'm running, not everything of the system, but I make a change. And then I assert that what I can observe is what I expect. So I have to be able to probe my objects or part of the system and get what I want out of it. And so a test, any test, is a sequence of at least one action and one assertion, right? That's all a test is. And that if I think about the structure of any test, we all do this, is that I have to set up the test. I want to declare, sometimes this is optional, sometimes people do this as a good structure, declare what they expect. You exercise the code of the system, you get the results, you assert that those results match what you expect, and then you deconstruct if you had any context that you need to break down, right? So
that sounds like a lot of work. I mean, do I have to do that for everything throughout the whole program? For every requirement, every little thing, I have to write a lot of these different things?
Well, so that's the outline of a good test. And if I'm, really thinking about testing, I need to think about what's important to test. Some things maybe are less important than others, okay? And what granularity do I want to test? Am I always testing tiny little methods, or do I test interactions between objects?
How about getters and setters?
Yeah, how about them?
Should I test those too?
No.
Okay.
Okay. So who should write the tests? If I'm writing unit tests, that's one thing, but there are other kinds of tests, load, performance, all these yada, 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 all kinds of other tests. And, who should run the tests? Is it only the developer's responsibility? When do you run tests? And how do you run them? All right. Does it go really fast? So I should only have tests that take a little bit of time and not a lot of time?
Okay. So I guess what you're really saying then, it's real important to think about what to test and focus on the important things, because otherwise we can get caught up. It's impossible to test everything, or I could spend all my time just writing tests forever, all these little scenarios. So I need to really think about what's the important scenarios, not just isolated methods, the important interactions, and the difficult parts, the important business logic based upon this.
So you really better spend your time testing that pi really is pi, not 3 point, whatever digits you want it. I mean, that it's really doing that calculation. Okay,
so really focus that. And then you talked about qualities, testing different system qualities as well. So I think that's very important too, is sometimes I think with, a lot of times when I'm out working with people in industry and they're doing TDD, they just you have your blinders and you're only thinking about the simplest next set of features that we have to implement with this sprint. Sometimes you forget about, well, what about performance or reliability or security? And sometimes those are some cross-cutting concerns. And so how can we think about how to mix those in? And so these are important things to think about as well. And then these types of exceptions that you were alluding to.
So that's still a lot to test.
Yeah, so it's just as important, I think, as we were talking earlier, is what not to test. Tests should add value, not just be an exercise. And the best example I have on this is even earlier this year, I was working with a very large company, TDD and Scrum, 2-week iterations. They had 6 teams around the world, 1 in India, 1 in China, 4 in the US. This is a very large company, one of the largest in the world. And this is very important software they're writing. And so continuous integration, they were really focused on that. And one of the requirements was at this company was that you must have 85% code coverage.
Not 86.
Well, at minimum. 86 is cool. Okay. 90 is cool, but you must have at least 85%. So one of the things so let me just ask you here, what kind of tests do you think that some of the developers wrote given that requirement? Anybody care to speculate? What kind of test might have been written and that you must have 85% code coverage or you can't check your code in at the end of the 2-week sprint and we can't get it in to, because all 6 teams had to integrate. I mean, this was 60 developers, teams
85%,
teams of 10 people, all doing Scrum teams, but doing TDD. Yes, 85. Yes.
I would say that they probably write a lot of tests.
But,
Oh, so you're just saying empty tests.
interesting. But you coverage, yeah. So, but some of the tests may not have assertions in them, but they may invoke to the coverage. So they were really just blindly calling methods just to get the coverage, so that they could get the coverage up. Or even the ones that did have assertions would just blindly, sometimes just blindly call something that were doing nothing useful other than to give you fake coverage. And in fact, my claim is I would rather have 10% coverage and 100% good tests, you know, than 100% coverage and lousy tests. What's more key here, and what's an important point that we're trying to make, is focus on the right test. And don't just have simple little coverage tests or getter and setters, unless, I would claim, if getter and setters have weird side effects. They're reading stuff and doing complicated things.
I don't think they should have side effects.
In general, they may not, but sometimes you may be reading values in, doing lazy evaluation from a database. In that case, maybe.
Sure.
And same way as sometimes every boundary condition, what if you have an infinite set of boundary conditions? There are problems that have that. So you have to pick the significant scenarios and test that you've handled those transitions, because that's where a lot of programming errors are done. Like Brian Merrick talks about with his testing, is people always, you know, we're always off by 1, less than or equal to rather than less than. So we need to check those boundaries. And if you try every exception, that could be pretty problemsome too.
Well, you know, as a tester, you do want job security, Joe, but, you know, there's stuff that we don't test. That's good. That makes me feel a little better.
And this isn't only for testers. These are for part of TDD is for the developer to even validate before they hand it off to QA what's going on. So I think that's what's interesting. And I think an important thing is TDD should be more than just unit tests. Unit tests are very important, but there are, let's take Agile is supposed to be the whole team. We're trying to get everybody involved and even let QA get involved early on to help us as developers. And so you may have integration or smoke tests, these different quality scenarios that you were talking about, and even your user acceptance tests. I mean, there should be lots of that.
And so when we talk about that overlap, really that when we think about the system design, the system functionality, the system performance characteristics, some of our unit tests touch on some of that, but also these other tests overlap. So that different overlap isn't necessarily redundancy. It's just another angle at it, getting at it from a different way.
Right. In fact, one thing that I believe is the fact that you could even work with QA, and QA maybe even helps you get a better understanding of how to define some of those unit tests. It doesn't mean that they're at the end of the cycle and you throw it over the wall. Here you go, test it now and let me know what's going on. It'd be good to know ahead of time what some of the issues are. As a developer, I'd like to know some of the things you're testing to make sure I'm handling the scenarios correctly. Yeah, that would help me.
Those testers always say that, you know, programmers really don't understand boundaries very well. You know, the boundary conditions.
Right. So explain it to me.
Yeah.
Help me out.
They have stuff to offer.
If you explain it, I can make sure to design my system better for that.
So, just to kind of wrap up, it's common really to think about TDD as only being the unit test part of the cycle. And gee, if I've done that, I'm a good developer, great. But we're saying there's more. There's more than unit tests. And in fact, if you don't take a broader perspective as a developer, you're kind of not doing TDD.
Yeah, so it's more than just this red-green unit tests. I need to understand tests better and be more involved.
Okay, so the question is, do tests help you build the right thing?
Yes, they do, but only if you have the right kind of tests and you still are committed to looking and keeping things clean and still looking inside the design. You still have to evolve the design, and what really should be focused is let's get a good picture and make sure we're understanding what it is that we're building during this sprint, and start off early on thinking what is the good ways to validate what that is, and make sure we write good tests, which may include also bringing in other people such as QA and business people, keeping them very involved so we understand that.
So if I'm writing superficial tests, they aren't going to help me write the right things.
That's right. So unless, that's why the but. So unless, yeah. So if you just write a bunch of tests, it may or may not. But if you have good tests, then they can help us be focused. But we need to think about what is a good test. And I think this is something that's not taught from my experience from working with a lot of people out there doing Agile, no matter what kind of developer you are, from small teams to big teams. If they don't understand what the requirements and how to validate and think about what good tests are, it's not going to help you build the right thing. So if you have just stupid tests like these coverage tests, then that's not going to do it. So, do tests guide development and keep you focused?
Well, I think when I focus on tests, I am very focused on the interfaces to what I'm designing, making sure that I'm getting that right. And they force me to implement the functionality really to make it pass so that I'm, instead of jumping around and tweaking, sometimes I have attention deficit disorder when I program. And if I'm doing testing, it really helps me focus on stuff.
But you may be missing the bigger picture, though. So how do you consider so you're in there, you're writing your set of components, you're the team in Portland working on your set of stuff, but I have a team over in Champaign, Urbana, Illinois, and we're working on these different services that we want to integrate through the cloud or something. Stuff you're doing might be affecting things that we're doing. And so how do you resolve these forces? I mean, TDD promises it keeps me focused. So how are you going to help me, deal with some of this?
Okay, well, so that's obviously something a little bit larger. The unit is more than just the class, right?
Yeah, I mean, your units might be fine for what you're doing, but what you're developing might be affecting stuff that I'd have to use. And so I want to make sure that, things are integrating and we're getting the big picture. We're staying focused. It's the bigger level. So how do you resolve these forces? Okay,
so Joe and I have both, we've had a reading book club here. I started reading this book, Thinking Fast and Slow. A true confession, so if you know me and you want to talk to me at the rest of the conference, I have a computer science and a cognitive psychology degree, so I'm very dangerous. Right? Okay, but one of the things that this book has influenced me to think about is that there's two kinds of thinking that we have in our, and we can't not do avoid fast thinking. Fast thinking is where I'm doing decisions based on my intuition. I jump to a conclusion. It's good to jump to conclusions rather than always spin your wheels, thinking slowly.
If a car's coming at me, I want to jump out of the way.
I want to jump right away. I have associations, so if I am writing some code and I'm in the groove of programming, I just know what to do. I write the next thing. I get in there, and I'm not having to do a lot of heavy-duty mental lifting. It's going fast, and I'm having a good time. On the other hand, sometimes there's this other kind of thinking where I may have to reason about something. Joe said, well, I need to stop, take a step back. I won't fall off the stage.
I hope not.
But I may have to do some reasoning about what I'm doing rather than just making that test pass fast as I can. I may have to take some logical steps. I may have to do some sketching. Sketching slows me down. Programming I can do really fast, but if I take time to sketch. So
it might be good, in other words, to step back is what you're saying, Rebecca.
Careful.
No, don't you step back. but it might be good to, maybe we need to get together and brainstorm the bigger picture at times and kind of, check notes and make sure we're staying focused with the architecture and things like that, rather than
your
just
concerns rather than just getting my test to pass.
Right. So rather than just my optimizing within my small area, I might need to also step back and think how my stuff affects you.
So how many of you do pairing when you program, pair programming? Not so many.
Well, quite a few. Yeah,
okay.
Wow. About a third.
When you're not, when the other pair is not sleeping, right? I mean, you know how that goes. Sometimes you're a, navigator. Yeah, I'm, if you're having to explain something if you've got the keyboard, you got control of the keyboard. If I don't just type and the other guy is snoozing, that actually is one way of slowing you down, is to have a conversation about what you're doing. Someone, and if you're the person who doesn't have control, and you're looking at what's going on and you're asking questions, as soon as you do that, that's getting the other person to slow down, at least to explain what they're doing, and then you have a discussion. That's why you pair, not so that one can sleep. Sometimes, though, that's not enough. Sometimes I need to take a step back and do some sketching. I call it design noodling, where I take a little spike exploration. I may do some alternative kind of what-if kind of programming, but we're doing it in a safe way. That's slowing down and doing a little bit of larger thinking.
So one of the things, I guess, when I think, a lot of times when I'm in that fast thinking, which can be good, we're into the fast moving, I'm really worried about this area, this small area, and I might be optimizing well, but I might be over micro-optimizing where I might need to think and step back. So one of the things with early on during your sprint, really thinking about and getting together and just brainstorming what are the right set of tests is a way of doing slow thinking as well. And another thing is we might be so caught up that we might just need to take a break and let's go over to the whiteboard and kind of draw or do whatever. As long as we don't do too much of that, there's really this kind of balance thing that you're talking about. Is you don't want to spend too much time with the slow thinking where we get caught up for many hours or days with all this. But you might even, like you said, spike solution, go off for this next sprint. This is very risky. We don't know how to implement it. So you go figure it out and do some experiments and come back to us in the next sprint. And then we can stop and rethink this after you do some experiments with that. And it's not just blindly writing tests, red, green, whatever, because we're not sure how to do this yet. We're experimenting with a new technology.
So on the other hand, fast thinking is kind of fun. When you're in the groove,
yeah,
when you're really going and thinking you're just fingers flying, tests turning green, it's just like a rush.
Yeah.
And so on the other hand, if you get going into that mode, sometimes you kind of get your blinders on about, am I really doing the right thing? So how many of you practice the Pomodoro technique? Anybody? Oh, wow. Okay, I'm impressed. A few people. What that is that I take time. I say, I'm only doing this for 25 minutes. For me, that's too short. I want to go an hour. But, the Pomodoro guy says, take 25 minutes and walk away. Get away from the keyboard. So when you do that,
take a breather. You're taking a break.
Guess what? Your twitchy, fast brain slows down a little bit, all right? And so that it actually allows some of that slower thinking to kind of kick in the background without you even thinking about it.
Right. So, for example, rather than just having that instant gratification, feel good now, how many stories can I get in? I might get a lot of stories in the short term with that instant gratification, but it can have major effects downstream that really affects things and can possibly make things worse. So what we're really saying is taking time to do both fast and slow thinking. So Rebecca, answer this. Do tests guide development? Do they really keep you focused?
Well, of course they do, but I need to sometimes step back and get focused a little bit on the larger context. Hopefully my colleagues, my fellow developers help me do that, all right? And that testing is only one of the ways. Just even communicating with people about what I'm doing, or what they're doing and how it affects me is important for that TDD cycle.
So something that we've put together, and actually I have these printed up in my suitcase that didn't make it, so if it makes it later, I'll make the cards available.
Yeah.
I have little cards you can take off. We put together like our top 10 list, the 10 tenets of testing.
We wanted 11, but you know, we only ended up with 10, right?
Yeah. So basically,
All
just
right,
to
Joe.
kind of give you a little bit of a review of it, the core of these is back to what we're saying, is it's most important to have the good tests and that you have good complete scenarios. You're focused on full scenarios, not half scenarios or multiple scenarios. So keep your tests focused based upon the right types of scenarios.
Well, so my favorite, not that we're going to go down through all 10, but some of my favorites are basically dealing with those limits and boundaries in exceptional scenarios. I started out my life as an evaluation engineer, and I have found that those sort of practices of figuring out edge cases helps me crisp up my design faster than anything else. So just getting the happy path working is not enough, but I like to test for how my system is supposed to respond to those edge cases too. And you know what? Oftentimes those user stories that people give us, they don't think about what should happen when things go wrong, and still we have to design something and implement something. So that actually oftentimes forces me to get the more complete requirements by having a conversation.
Yeah, that's very good, because that's where, as you say, where most of the problems in what we're developing, that's where it happens, is that's where the harder parts are. Now, and then just to kind of to throw one more thing on here, once again, we're not going to go through all these, but we'll definitely give you our list, and we'll make these slides available as well. But one of the most important things is the biggest mistakes I see with people when I went into this large company. Where do you think I found the messiest code? In the tests. Exactly. Code duplication, all these other things, and pretty soon the tests were holding you back from even evolving the code, because they were so messed up that in order to fix something, you had to fix a lot of tests. So one of the things I did like, though, is one of the top level guys that was leading all these different teams, he was trying to push that the test code is as important, if not more important, than the production code.
Oh, you mean you need to design your test code, huh?
Yeah. I mean, it's code, and it should live with it, and it's important. For them, it was key because they were in one of those regulated industries. So if they changed, their test could really help validate that things stayed correct. So being lazy, it's easy to get lazy. Oh, it's just throwaway code. Well, if you're going to really throw it away, fine, but these tests were important and wanted to live with that.
Well, so tests really aren't throwaway code.
No.
In fact, testing is really important. And so we couldn't get away with just 10. So the underlying assumption about well-designed tests that we want to say is that, you know, sometimes you might need to verify that the tests are okay too. So not to get recursive and meta on you or anything like that, but who tests that the tests are really working?
So we wanted 11, so we added one.
It's number 0. So you kind of want to verify that your tests are correct, but you don't want to just say, oh, it passed. I got a green, so therefore my test is correct. Hopefully you know that that's like silly. That's not enough. And so we've been actually picking up some techniques for making sure that you're, proving that your tests are better, at least proving in some sense. I might, for example, change, if my tests pass and I haven't, come back to this test in a while, what I might do is actually take something in the production code that I'm testing with that test, change it so that it doesn't work as expected, and see that my test fails.
Right, because otherwise, we just did a big assessment recently, and they had some tests that weren't testing anything, and they were always passing. And they didn't find this out till later. So just because you add a test and it's green, if the test isn't really, so you want to validate that that test is really testing the scenario. So if you're adding a new test, a good way to do that is to try that. Break the code, or do something to ensure that it really did test that scenario.
So I actually might read the code of my tests,
Or remove part of the test, see if it causes it to fail. If your test is really good, if we remove part that's setting up or doing certain things, it should cause a red when I remove some of that.
I mean, these are like, okay, these are like very simple things to do to get you out of your complacency with tests. Or, you know, taking a test and, not that I want to do cut, copy, paste, reuse. I'd like to refactor tests, but sometimes I might want to copy a test and make a slight variation of it that I think will also pass to see whether it will pass, or a variation that I think will fail and see that it will fail. But these kind of things to kind of like jar you out of your complacency with tests.
Right.
Exploratory testers talk about, you know, sort of digging around in the system to find the edges of the implementation, but we're saying do this on your tests from time to time too. Just keep yourself on your toes. Do not be complacent about your tests.
And one thing I like about the variant that you were telling, most times on the variant that I like to think about is take the scenario that I'm doing, and the variant is just a little off.
Just a little bit.
A little bit off, so it should fail. In fact, it should be one of the failing variances. So that might be a good way. In fact, I could even then turn it to an assert, you know, the opposite is to accept
and
afterwards.
Use that as a
yes,
test. Yeah.
And use that as a test, exactly. So these are just some techniques that we're looking at.
Okay. So given that tests are an asset, one of the questions is, do I always have to write tests first? Test first, you know, test-driven development, does that mean test first?
Well, if you talk to Uncle Bob, you're not doing TDD unless you write your test first. I mean, he's very hardcore, and some people are definitely hardcore about this. So if you're really going to create your test first, in fact, the claim is it's a common belief that you're really not practicing TDD unless you write your test first. And that's kind of the purest, religious, dogmatic view of what TDD is.
Yep. So that's true. And I was, we have an Agile open space in the city where I live. Every year it alternates between Seattle and Portland, and this year there was a session on TDD for slackers. Somebody had this because they started out saying, well, man, is it okay to write tests after I write some code? I'm feeling guilty, but I'm doing that. All right, man. And so there was an open space session that someone else had, and I went there and I said, well, are you checking your tests in? Okay, so the question is that cheating if I write the tests after I wrote some code? Am I a slacker? Does this mean that my code's going to be bad? Does it mean my design's going to be bad? Does it, you know, if I don't always write the test first, is that going to reinforce my slacker tendencies and I'm going to fall away from the true religion of TDD? I mean, those are good questions to ask.
Well, let's examine that some.
Okay.
So I mean, like Uncle Bob says, I mean, this is what we base this on. If you really think of it this way, is the common practice that's taught when you're really learning TDD early on, if you want to do it by the book, or Kent Beck, or the other people saying it, they really focus on this. But in reality, they start with test first, as we said. But in reality, a lot of times when I go out and work with a lot of different developers, they might be thinking a little bigger than that. They might be thinking of a few classes, experimenting a little bit. So it's not always the case that you just write the test first. There might be some other things that you end up doing. And so another way of thinking about this is more of a pragmatic testing cycle that we're trying to promote. So the most important, once again, we said, is to start out defining the importance acceptance criteria. Let's think up front what that really is. And then, I don't care, write your test first. Or if you write a little production code, I work with somebody, John Brandt, the guy that implemented the first refactoring tools and refactoring browsers. This guy thinks real advanced. He'll think about a few different things and then he writes a lot of tests for it. That's fine too. That's not cheating, as long as you write some tests. And, you know, and make sure that it passes. And at the end of each, when you get this implemented, that test code must be there validating and checked in too.
So I actually have Kent Beck's story. You know, Kent Beck doesn't always write his tests first. I knew of him from Tektronix. We worked together, right? And I was at Tech Labs at the same time Kent was. And Kent and Ward would be doing the first pair programming, writing applications for Smalltalk. And I was implementing the Smalltalk. So that's kind of my relationship to them. And when I first came up with responsibility-driven design, I wasn't inventing it. I was trying to follow, he won, I guess, all right. Trying to follow what good testers do. And the real case is that as long as at the end of a cycle, and a cycle being a short cycle, I had tests that proved it, and we used it in the, we had it in, a different way of doing it. We didn't have the frameworks for testing, but we had the workspace that you would write your tests in, and then you also had test methods for classes. At the end of the cycle, and the cycle might be 30 minutes or an hour, as long as you had tests, you were okay. So, not even the guys who invented the religion always did it first.
What was important, and Rebecca made an important point that I want to just bring out, short cycles and good tests, I think, are key to this. As long as you have, that's what's key. So we don't really care one way or the other. If you want to be a purist or dogmatic about it, then okay, write your tests first. But if you write a little bit of production code, and I see this, the real people practicing, if we've got a lot of developers and they're not testing at all, and if we get them to write any tests, I'm happy. At least we've made some progress. So if we can even get them to start writing tests regularly and checking that in and validating their things, that's a big step towards being test-driven.
Yeah.
And most important about being test-driven is that start side over there, too.
Right. So you're driven not necessarily first.
Yes.
It's our point of view. And so I really want to kind of focus on alternating between writing tests and writing code. Now, whether the chicken or the egg comes first doesn't mean you're a slacker as long as you check it in. Okay, it's okay. It was interesting at this Agile Open Space where the guy who had this session about slackers, TDD for the for slackers, and he started out being very apologetic about this. And there was one guy there, I will not name him, but he's well known in the Agile community, and he says, "Oh, you are a slacker. You're going to go to hell." And basically what I said was, "Are you checking in your code with tests that work? Is it the coverage you want? Yes. You should feel okay." And so we got into a kind of a fight because that's actually a very controversial thing. And I said, "Well, if you're getting tests, you have a class that's testable, you have the right interface to let it test. That's the goal, isn't it?" Right?
Yes. And so we're asking you to rethink this and challenge this, because the norm of TDD is this would really be violating it. But can you actually, what works best, and different people think differently. So if you're really being agile, we're not supposed to be so strict. We're supposed to be adapting the practices to what works best for the people doing it. And that's really what Agile is about, not like this strict thing. That's rigid. That's not Agile. Agile is supposed to be really thinking about what works best for those people doing it.
So do I always have to write tests first?
Well, no, as long as the tests are checked in with production code, and as long as you're really thinking about what good tests are, and as you pointed out, the short cycles, that's key. So if you need to design a little bit, do a spike solution or experiment how this is going to be, and then write the test, or maybe you're writing a few classes interacting, as long as you think of the important scenarios and how to validate those and write those tests and that's checked in, then you're okay.
Okay.
So, one of the other promises that we said early on, we had all these promises for TDD. Do tests allow you to change code safely and quickly? We should think about that.
Well, I think that hand in hand with testing is keeping your code clean, whether it's their test code or your production code. And so there's this notion of refactoring, right? So if I don't do refactoring, I don't think that you're going to get to safe, clean stuff at all. Now, Martin Fowler has this notion of having refactoring being something you do daily, like flossing. We all floss our teeth, don't we? All right, you're supposed to be doing this commonly, right? If you don't and you get my age, you end up with your teeth falling out. So, I mean, it's the same thing with refactoring, is keeping, keeping your code clean, and it's something you do all the time in little bursts, is what Martin Fowler says. So it's not just that I'm making my test pass and I'm happy. I may be refactoring, which means I may be creating smaller methods, helper methods, all kinds of little things. So that's the common wisdom of working refactoring into your daily routine. Now, it's interesting, talking about dental work, is that these are two folks that I know. Andrew Black is a guy that is a professor at Portland State. I live in Portland, outside of Portland, Oregon. And Emerson Murphy Hill was one of his students. And they actually did some studies about 2 different kinds of refactoring types, and actually instrumented tools to see what people were actually doing in their Eclipse browsers using the refactoring tools. And they found that there were 2 different kinds of refactorings, those what they call floss refactorings, and I really like that, because you're supposed to be doing those daily. Frequent, small changes, intermingled with other programming. That's kind of the daily health. But also, the case is, and it was interesting, I highly encourage you to look at that article to see how much people are not using the refactoring tools when they should be, that could be doing that. But that sort of daily routine is one thing to do. But then there's also the root canal refactorings, is what they called it. Doesn't that sound painful? I've had one root canal. I don't like it. But sometimes you really need to dig in and replace, not just superficially, but I have to majorly think about my interfaces need to change. I have to restructure and redesign, not just move code around. And technically, the floss refactorings aren't supposed to do that. Okay.
Obviously, out of those 2, I know which one is easier to do.
Yeah, let's do the daily stuff.
And that's because it's a lot of small type things coming from the refactory. Is if you're taking these small things, it's a lot easier. Though sometimes, even if you do the small things, sometimes some things can come up with new design change. You have to do some major changes, no matter what. So, if I have to do the daily refactorings, life is cool. But what happens when I need one of those root canals? Sometimes you do. What if my tests, all those beautiful tests that test the interface, and now I'm going around and restructuring it, what if they become a barrier? And I've actually worked with a number of Agile teams where this is a real problem. We can't change our production code because it would break our tests. Yeah, and in fact, as we discussed earlier, one thing is, it's just important to think that your test code is, to design your test code is just as important as your production code, and it needs to evolve. And a good example I have is this same large company that I did some work for earlier this year. They had a lot of tests, and then they had these frameworks, and a couple different teams from the different Scrum teams were extending and using this framework, and they both had like some repetitive variables and methods, and so I'm like, hey, let's just refactor. I'm from the refactory. Let's just refactor and move this up, and you have lots of tests. Well, they were like, oh, but it might break the test. Well, refactor your tests. That's what I think. I mean, before we called it TDD, and even extreme programming came about, one core principle of refactoring early on, with all the early work done, was that you must have a lot of tests to make sure you broke nothing during refactoring. So refactoring and having a lot of tests was going to help you when you had to evolve your design. It would help keep it clean so you could change your code more quickly. But it's important, if you don't evolve your test code and do all that you won't get that. So it's important to do that. Lo and behold, though, sometimes it just takes a lot of courage to say, these set of tests were good for that design, but we have to refactor so much. It's easier. You know, it's okay. Throw it away, the test, and rewrite them. That's okay.
Well, so oftentimes that courage is, sometimes it's because those test codes were poorly structured or they had a lot of hardwired stuff in there. But sometimes it's because I am changing the interface to things and darn it, I need to do that. Right? Both cases, I might want to throw some test code away.
Yeah. I mean, if it definitely slows your ability to change what you want in production, then you should rethink whether you want to keep them or refactor them or just throw them away. It's okay. I've had to do, and one of the things with the big ball of mud paper, which it relates to this, that Brian Foote and I were talking about, is sometimes there's no refactoring that will get you out of the mud. There's no way of cleaning or just wrapping it, sweeping it up. Sometimes our last pattern in that sweeping it under the rug was called reconstruction. Sometimes you have to just tear the building down and just build a new one. Same way with tests, because this is supposed to be good, important code too, so you need to be willing to take that risk sometimes.
So if tests are legacy tests, throw the suckers away.
Yep, exactly. So, do tests allow you to change your code safely and quickly?
Well, yes, if they're light on their feet, but if they're a barrier, look at them and see why. Because then you might need to do some test investment, right? That's another way of calling it instead of just throwing it away. Test redesign, redevelopment.
So, do tests, how about this? Do tests help with quality code? This is one of the promises too of TDD. A core promise is that tests are going to help you still end up with quality, or TDD practices will help you with quality code and good design. So will tests and doing TDD help you do that?
Okay, so I want to briefly talk about what I think good agile design is. Design simplicity, right? We don't want to over-embellish. We'd like to, from a design team, you know, our code needs to communicate its design intent. We don't create a lot of other stuff to communicate it. It's understandable by a team. As designers, we trust each other, but we're making sure that our code satisfies stakeholder needs. And as we go, we need to keep learning. Otherwise, if we don't, as Ward Cunningham says, if you don't refactor your code and put the learning in, you're ending up with technical debt, right? And then we need a lot of testing too.
So, for example, I think you have a good quote about XP I like, because speaking of retrospectives, which we're going to talk about tomorrow, but you keep learning. So, I mean, with XP, you have this good story I think you should share.
Oh, yeah. So, I've been the shepherd for papers at the Agile conference on Agile experiences, for the last 10 years. So, since the dawn of time. But anyway, one of the guys that I shepherded, he said in his paper, if you're doing XP the same way you were doing a year ago, you're not doing XP, because you need to be learning and growing as you go. I mean, your practices need to be tuned to how you're getting smarter.
So that's very key. It's not like I just learn it by the book. We're supposed to be, okay, I learn it by the book at first, and I should do it by the book at first.
Absolutely.
But then, but learning and constantly reflecting on how we can make this better for our team, and that constant improvement is key to this.
Right.
And also, one other thing too is you talk about, I mean, you were talking about some Agile design values. How about some Agile developer values? How do you think about that?
Well, I mean, if I think about classic test-driven development, I implement story by story. I'm running the test. I'm making it fail. I write the simplest code again to get design's simplicity in there, make sure that the test pass, and repeat until the story is tested and implemented in a way that the design is not hollow or shallow either.
So this is from test first type.
Yes, that's the, and when I think about where design happens there, you know, good development practice, while I'm pairing with somebody, the design thinking happens hopefully because I'm pairing and talking to someone, not just banging it out. Between the keystrokes, we're talking, we're having conversations.
So this is your classic test first.
Right. there's another view that Scott Ambler has talked about for test-driven development, where sometimes we need to do a little bit of modeling or work, particularly for building a new thing before we start. We may want to envision and do a little bit of architectural noodling where we're developing some code and throwing it away to get some ideas. And then for iterations we go through, if we need to do some new stuff with some new domain concepts, we may do a little bit of modeling before we go into our TDD story cycle. So
notice, I mean, almost all people that I've gone to that really get caught up with more of the dogmatic TDD, they skip iteration 0. Even though it was talked about originally when TDD came out, is this envisioning, look, it says days, weeks, or even months. Are we even building the right thing for our company? And then even when you get into the sprint, as Rebecca was talking about, it's still okay to get into a little bit of this brainstorming, this slow thinking.
But it's only a few hours at most.
Right. So there's still kind of a mix of that, and I think most people miss that if you just get caught up with the instant gratification, red, green.
And sometimes, if life gets tough, talking about where I might have, not just at the keystrokes, talking to my buddy where I'm pairing, sometimes I may have to go and do some spike solution. And the original XP description that's on the web, that Don Roberts has on the website that he has, is put a pair of developers, and you see this, on the problem for a week or two. That's like spiking for a long time.
Yeah, so that might be, I mean, you're not writing tests then, you're experimenting and thinking about how to implement this other design that might be very hard but core and risky. So we have to go, we're not sure yet, and we need to put some of our best team members here, go find out, what do you think we should do with this new persistent thing or this complicated business rule thing here? How do we implement this even? So
that's the case where I'm not being test-driven, but I'm doing some development to figure out.
And that's still part of TDD, I mean, as it evolved even from XP. And in fact, some interesting facts here from, there's been some research done by Steve McConnell. He's well known in the industry and researching a lot of this. He put together an article on the best ways to find bugs in your code. And what's interesting in this is when you look at this, is he says, well, look, a regression test will find, 20-some, 25%. Oh, unit tests only find 30% bugs in your code. I mean, he was looking at lots of developers, lots of people doing this, not
just Microsoft.
Yeah, not just Microsoft. He was looking at a lot of areas. And then, it has new functions, integration tests, high-volume beta tests. Wow, that got the highest, more than 1,000 users. Look, even modeling and prototyping gave you some, or code inspection. So he looked at all these different techniques and noticed that no single one really got you up.
So if you think about that, for any one technique, and whether these numbers are off by 10%, I don't care. The average is around 40% of the bugs that are found with any one technique. So I hope that you feel uncomfortable that unit tests are getting everything that you need to do.
Right, but what's also interesting, if you continue reading this article, even though no single one writes higher than 75%, if you combine these techniques, if you really start adding unit tests plus regression tests, plus design reviews.
Or a little modeling, maybe.
A little bit of modeling. He noted that. And if you really combine all these, you can get higher than 90% on testing that. So unit tests alone, it's still good to do some of these other practices if you're really trying, if it's real important and you need to find these bugs and ensure reliability with your code.
Right. So I think, just to make it clear, our advice is not to go out and do all of these techniques, because that sounds tiring and probably isn't the right thing to do. But adding one or two based on what you think might give the most value.
Exactly. In fact, one of the things that for example, we just did this assessment, I said, down in Brazil here a few weeks ago for a very large organization. They have 7,000 internal IT people. They hire another 6,000 external IT So we're talking a very large number, things. And so they're trying to become agile. They're not very agile right now. They're very waterfall. And they've brought us in, and we're helping them with some of that. One of the big things that we're pushing is it depends. So depending on the type of project you're doing or the type of risk, the scope and the size, you might pick a different set of techniques or team members. What works better for us? Let's bring QA and have them do some regression with our unit tests. And plus, we as team members will pair and do review of the code as our pairs move around and help with that. So if you mix a few of those, depending upon your team size and what you're doing, whatever makes the most sense is what we always like to say. That's true with, that's really what Agile was all about, not just buy some tool and just do it by the book this one way.
Even though you love refactoring tools.
Yes, yeah. Obviously I love refactoring. I'm not against tools, being somebody that part of the people that did the first commercial refactoring tools or even invented the term refactoring.
So tests are a part of it, right? So do tests really help with quality code? I mean, what's their contribution versus all these other things that we might do?
Well, they can, but you really need more than tests. You really need, you need to do the mix of these other things is what our real point here is. TDD is supposed to be bigger than just blind unit tests. You need to think of other things as well. It still takes a commitment. Part of TDD is refactoring, keeping your design clean, mixing other types of techniques. So think of the bigger picture. Just don't get caught up with the instant gratification for these user stories and the red-green on this small part. Let's try to get focused on the bigger picture.
So if you're doing that, you're not doing enough.
Exactly. Obviously, you still want to do that. That's key to TDD, is still doing that, but there's more.
Enough.
It's not enough. Exactly. Okay,
so one of the things that we wanted to let you know about is if you go to agilemyths.com, we're trying to get people to think a little bit outside of the box because Agile's been around for 10 years or so, and there's some, I'm going to say, myths that are out there in the world that actually get people turned off from Agile because they go, oh no, my situation is a little different. So, for example, one of them is that simple solutions are always best.
You can't do frameworks if you're doing Agile, because that's not simple. That's hard.
But sometimes that might be more effective, depending upon the volume of use that you're doing. Okay.
And that is a myth, because I know people doing in fact, if you look at what Don Roberts and Ralph Johnson talked about with their evolving frameworks, they're exactly saying to do it in an Agile way. And you keep incrementing and taking requirements and growing the framework, evolving the framework based upon those things. So Rebecca and I are trying to put together and start capturing, and we encourage you to go to here and add more information if you have some myths you know about, but we're trying to be myth busters or find out basic on these myths, what works or doesn't work. Because for example, a lot of them is, I'm doing TDD, sometimes the top level business owner gets caught up with the trap. Because I'm doing TDD, we can real quickly, continuously over the next many, many years, change the system quickly. But sometimes the system still grows big, and it might be hard to still add some of these features because what you're changing might affect a lot of the system more than just this. It's more than just what might appear like this little feature that seemed like this other feature that was easy to add.
Right, well, so if I'm adding something, all of a sudden it might break my assumptions about why my architecture works. So,
you might need to refactor your architecture.
Yeah, well, I might need to do one of those root canals. And where they say, well, man, TDD, you're doing your daily flossing. Why do you need that? Well, you gave me a new requirement, right?
Right.
Okay, so these are some, point you to some of these things. But really, if you think about TDD and what we've talked about so far, is that want to leave you with a thought that unit tests aren't enough to get quality. They're sufficient to get you a baseline. But should they be your main focus? they should be a focus, but is it the only thing you're doing if you're really doing TDD?
And you know, it's one thing about tests too is they can give you this deception that if we just keep adding all these tests, we're inductively proving that our program's becoming more and more correct. But if you don't have the right tests, because it's probably more deductive and example-driven based upon these scenarios rather than an inductive way. So really, it's more important to focus on the right types of tests. That they're valuable, but we really need to think, what are these right kind of tests?
So if I'm thinking about tests in general as well, if they slow you down, and I actually feel very sad when people say, I can't change this one thing in production that's really bad because it would cause me to break some tests. If tests constrain code, it's like there's a problem there.
Also, let me point out why the white squirrel's on there.
I was going to ask you about that.
In case you're wondering why I put a white squirrel on there. I'm from Illinois, Champaign-Urbana, Illinois. And if you go where I live, and this relates back to this inductive proof of test, all the squirrels you see are brown. Occasionally you see gray squirrels. So you might think, well, all squirrels are brown or occasionally some gray. So I write tests around that. But lo and behold, if you go down to Olney, Illinois, and if actually you Google white squirrels, they actually have white squirrels down in southern Illinois. So Illinois doesn't only have brown squirrels, even though I've never seen one, except on the internet. But Dick Gabriel, a friend of ours, has actually been down there. Him and Dirk Reeler, went down and took some pictures of these white squirrels. They made a big thing. I'm not sure exactly how they came into being down in southern Illinois, but I mean the same way with tests, if we don't have good scenarios or we don't have a complete set of scenarios, you may not be getting the whole picture. So, and also one thing that's key is the whole team. Is Agile's around the whole team. TDD definitely focuses on developers with the unit tests, but as TDD being part of Agile, we still need to take the whole team picture. Where does QA, for example, fit in on this?
So they should fit in, yeah. So at the end of the day, you want to give you thoughts about being dogmatic versus pragmatic. And if you're dogmatic, some synonyms for that are bullheaded, right? That's a mean, ugly dog there, right?
My way or the highway.
Right. You're being dictative. You're being fanatics. You're
not doing TDD.
You're being intolerant if you're dogmatic. On the other hand, and don't you like that little puppy? I'm trying to sell you a puppy. Okay. If you're
little puppy.
Yeah, if you're pragmatic, you're being common sense, you're being logical, you're being practical. It's not so exciting, but puppies are fun, okay?
In fact, they're more agile. Puppies are more agile. This seems more agile because you're more flexible rather than my way or intolerant. Intolerant seems anti-agile. Dogmatic seems anti-agile. This seems, when I think about it, much more agile. The puppies are much more agile than, you know, when I was younger, I could flex a lot more than I can today, right?
Yeah, we don't want you to fall off the stage. Okay. So if we're being pragmatic about TDD, here's our parting thoughts. I want to have the right tests. That's what's most important. How I get to them, you know, if it works for you to write your tests first, go right ahead. If you want to write some code first, okay. It's all right. You're not a slacker as long as you check in your code with your tests.
And let's keep our test code clean. I mean, being somebody that finds code smells, and I'm a big, you know, like, and when I look at tests, I don't want to see all this duplication so that when I have to change the test, now I've got it duplicated in 5 places. I mean, test code is still code. Keep it good design. Everything we know about good design and patterns and good practices, we should also apply to our test code and refactor.
So if I'm doing testing, if I'm being test-driven, I have a different mindset and say that basically tests should enable change, and when they don't, rethink what your tests are really doing for you. If it slows you down, maybe they're a barrier and they need to be reworked. The other thing about testing is that it's too easy to get into this twitchy video game mentality of red, green refactor. Let's just do it faster,
Come on,
faster.
more code, more tests, more
Right.
code, more tests.
So sometimes you need to slow down. And if you're not pairing when you're doing the testing, try that, okay? Do some design noodling. Go explain it to somebody. Switch a pair if that guy's always sleeping, right?
Yeah, go take a break. Go and share with somebody. And you know, and what's key here is Agile is a mindset. It's not a specific set of practices. It's not a specific set of tools and do it exactly this way. I really like that quote that Rebecca had gotten from the experiences, is that if you're doing XP a year from now the same way you are today, you're doing it wrong. And I would say the same thing about TDD, is you really need to think what's the whole picture, and it's the whole team. It's more than just me as a developer writing a bunch of tests, they fail, and then writing some code to make them green. How does quality control fit in? How does QA? How can they help? How can we get everybody into this and make it work?
Yeah, if you're only doing unit testing, you're not doing enough to be saying you're doing TDD. That's my opinion. And I'll stick with that.
Yes, yes. And so something that we did, we have lots, and we'll make these slides available, lots of resources. We actually even have been out really pushing and teaching pragmatic TDD. And with some courses, we're looking at writing an online book about it. But we definitely wanted to leave some time for some questions. So even though we started a few minutes late, I think we've made sure to do that, is to finish on time, a few minutes early, so we have some time for some questions. So thank you once again. It's great to be back at JDD. I really like being here in Poland, so I came back again this year, and good to see people. And hopefully you dialogue with us. We're definitely open for discussing and dialoguing with people with this.
Okay. If there's any questions, folks have.
Yeah, so thank you.
Thank you very much.
Thank you very much for the presentation. I'm sorry. So are there any questions?
Yeah, what questions do you
Or
have?
points or challenges.
Yeah.
It doesn't even have to be a question.
Just hold on.
Does it work?
Yes, speak into it. It works.
Okay. Yeah. Do you hear me? Okay. So, what's your opinion about testing private methods? Because there are different.
Yeah, we didn't get into those details. Good one. You want to take this?
Well, so a private method. See, I've had debates with Mike Feathers about this, and you know, he has said, well, I should really just make everything public so I can test it, because I want to probe anywhere. I don't want to be constrained. Well, from my point of view, that's kind of leaning on the side of tests, as opposed to defining an interface that you know, making it clear that a class has a public interface means that you make stuff private, okay? And so if I'm making stuff private, then how those are invoked are by public methods, obviously calling the private methods. So if I have the right tests for the public interface, then the private stuff should get exercised. Now, if I find myself needing to access a private method to determine some kind of state value from the test, sometimes people do that, then I might want to rethink whether it really should be private or not. But I believe in the separation, particularly in Java, of public from private. And that's an important design decision for people who are actually using the code, not just the test code. So there are ways to get around it, but I really think that you need to preserve encapsulation and design public and private stuff. Maybe I would say protected, because I like to override stuff.
Thank you. I was going to add
private
that, so
meaning,
thank you.
yes, okay. But I do think that I don't have to dogmatically test every private or protected method, because if I exercise my public interface, I might read the code, but if I'm looking at the public interface and exercising it properly, I don't want to. So I'm a little, I have a different opinion than some folks out there that are dogmatic.
And something I might add, one of our tenets was definitely respect class encapsulation. And so in general, strongly agree with everything Rebecca said there. The only other thing I might add is occasionally, if you have to, you might write a special hidden test accessor and you name it accordingly and maybe make it compile out or whatever, that can during tests maybe get to some internals if the rare case you really need to, after you run the scenario, look at some internals. But most of the time, that's not the case, so you really should still, and I'm glad you said protected. I think private is abused, and protected gives you the same thing, but still allows a little more flexibility.
Yes?
Maybe not a question, but I think that if we need to test the private method, it might be the first sign that it's doing too much, and maybe it should be another component that we should test with public interface.
It's a smell of some kind. That's
Good point.
Michael's point is now and then the question is, are you really testing the right thing? Because sometimes people are looking for precise results back of something on a file structure or some, and maybe that's overly constrained. Is that really a detail that should be testing for? Maybe there's a higher level view of what you're testing as well that you should be doing. But it's a smell.
Yep. Other.
Wait, what do you think about testing GUI controls by unit tests? Are the right
GUI?
way? GUI, yeah.
Okay.
Oh, how do you?
Yeah. Well, well, sometimes there are frameworks that can help, but it's hard to automate everything, and GUI is very hard. I've talked to like some of the top testing people, Brian Merrick being one, and he said, and even he's still, and he's big proponent of even dogmatic TDD, but he comes from the testing community. GUI can still be hard. Now, sometimes there are some frameworks you can buy that helps with that, but really what it comes back down to is if you've done a good separation, if you've really used MVC properly. We got to just hear Trygve, the inventor of MVC, at a talk a few days ago. It was very nice at a conference we were at in Tucson, Arizona. But one of the things there is are you testing your model? Are you testing the business rules? You should still be able to do that. And sometimes you can still kind of fake some of the GUI stuff to test the internals. Though sometimes you still need somebody just to open the GUI and still run things. Or if you can automate it, then that's great. So you still need to test some of it, but sometimes it's hard to automate. It's more important when you're doing your unit test side is to focus definitely, do we have a good model? So if your business rules are in the GUI, that's another smell, right? It's another potential problem that maybe we need to pull that out and refactor that code.
So we did a class, and one of our students that attended our class this year was always writing a lot of GUI tests because that was what they had to do. And they were always breaking because people were checking hard-coded names of things. This is in JavaScript, going along with Java code. And we challenged him and said, man, perhaps what you really need to be doing when you're doing, if you are doing GUI testing, to be thinking about making sure that you're testing the right things. So oftentimes, when we're writing GUI tests, particularly for JavaScript code, I can get anywhere, right? So I can look at anything, but you have to think about at what level do I really need to be testing the GUI, and that's another concern. We could talk a lot about that, but
so for example, when the style sheet changed with that, then that broke the test. Something that simple.
That's a problem.
Yeah, that's a problem. They were testing the wrong level.
So in the interest of time, I think we're done. Yeah?
Okay. Definitely looking forward to talking to people more. Thank you once again.
Thank you very much.
Thank you.
Thank
We're
you so
around,
much.
so.